Hello everyone, welcome back to Quantum Science Hub. In this video, we will discuss Chapter 3 of IGCSE Chemistry, Stoichiometry, based on the latest Cambridge IGCSE syllabus. Since this chapter includes quite a lot of content, I will divide it into two parts and this video is part 1. So, let's get started. First of all, let's talk about molecular formula structure. Molecular formula can be determined if the structure is known. For example, if I ask you, what is the molecular formula for iron pentacarbonyl or lactic acid or alcohol compound? Do you know what is the molecular formula or the chemical formula for this structure? Of course you don't. But if you know the structure, then you can determine the molecular formula. You just need to count how many elements that exist in this structure. For example, in iron pentacarbonyl, how many Fe exist in here? 1 Fe. And how many C? 1, 2, 3, 4, 5. So C5 and how many O? 1, 2, 3, 4, 5. So the molecular formula is FeC5O5, right? So we don't care about what is the bonding in here. Is it triple bond or double bond or single bond? We don't care about that. What you need to know is just to count how many in this structure, okay? And for lactic acid, how many C in here? There are 1, 2, 3, C3, right? And how many H? 1, 2, 3, 4, 5, 6. So H6 and O3, right? So the molecular formula is C3H6O3. The same thing with this alcohol compound in here. The molecular formula is C5H12O, okay? Next, to write the chemical formula of a compound, we must know the valency of the species, elements, or polyatomic ions involved. Let's look at this table. So, as we know, group 1, group 2, and group 3 in periodic table, they are all metals, right? And all metals will have positive ion. So, take an example like lithium. So, that means lithium in a group 1, okay? So, that means lithium is Li positive or Na positive because the ion is positive. While group 2, so the ion here is 2 positive. Group 3, so that means the ion here is 3 positive. So Be 2 positive because it is in group 2. Mg 2 positive. Aluminium is 3 positive and so on. Okay, the same thing with the nitrogen, oxygen, and fluorine here. So nitrogen is 3 minus, while fluorine is negative, or chlorine is also negative. The valency of transition metals are indicated between brackets. For example, copper can consist of copper 1 or copper 2. So if it's copper 1, then you have to put the bracket 1 in here. If it's copper 2, then you have to put the bracket 2. So copper 1 means it is Cu positive, right? While copper 2 is Cu2 positive. And iron can be iron 2 or iron 3. If it's iron 2, then the symbol is Fe2 positive. If it is iron 3, then it is Fe3 positive. Lead. What is the symbol of lead? Pb, right? Pb4, so that means Pb4 positive. And the valency of zinc and silver is fixed in this syllabus. Zinc, Zn, it is a valency of 2, and silver, Ag, it is a valency of 1. So that means Zn is 2 positive, while Ag, silver, is positive. Okay? There are some polyatomic ions or a group of different atoms. For example, hydroxide, the symbol is OH minus. So the ion here represents the charge in here. Okay? And this is all the ions that you have to memorize. This is very crucial to determine the chemical formula of a compound. Okay? Some elements exist as diatomic molecules, which means that they are molecules made of 2 atoms, like hydrogen, nitrogen, oxygen. All halogen or group 7 elements like fluorine, chlorine, bromine, iodine. Next, here is the methods to deduce the chemical formula. First of all, write the expected valency and crisscross. So we know the valency of sodium is 1, while oxygen is 2. Or I can say sodium is Na positive and oxygen is O2 minus. So the chemical formula here is Na2O. Next, if we need to place a number for polyatomic ions, a bracket must be used. So in here, Al is Al3 positive, while OH, the ions, is OH negative, right? So I will take yours and you will take mine, crisscross. So become Al in bracket OH 3 times, okay? Next, simplify the ratio by a common factor if possible. So this is Pb4 positive and this is O2 minus. So when they make a bond, so they will become Pb2O4. And then you simplify them because both of them can be divided by 2. So it will become PbO2. Okay? So the chemical formula here is PbO2. The same thing with Mg2 positive with CO3 2 minus. So the chemical formula is MgCO3 because both can be divided by 2. Simplify them to become MgCO3. Okay? Okay, now let's try some word example exercise here. Let's see this table. This is all the species including atoms and ions. So K potassium. So potassium here, the ions is K positive because it is in group 1. While nitrogen, it is N3 negative. So I will take yours, you will take mine. So the chemical formula is K3N. Okay? While calcium is Ca2 positive and sulfur is S2 negative. So I will take yours, you will take mine. So they will cancel each other, simplify them, become CaS. Next, NH4 is positive 1, right? While NO3 is negative 1, nitrate. So it will become NH4NO3. Lithium is positive, while oxygen is 2 minus. So it will become Li2O. Ion 3. So ion can be ion 2 or ion 3, but this one is ion 3. So Fe3 positive. Oxygen is O2 negative. So I will take yours, you will take mine. So become Fe2O3. Next, Mg. Magnesium is Mg2 positive. Fluorine is halogen F negative. So I will take yours, you will take mine, MgF2. Next, lithium, positive SO4 sulfate, right? 2 negative. It will become Li2SO4. Silver, Ag, is positive, while hydroxide OH is negative. So it will become AgOH. Lead-2. So lead-2 here is Pb2 positive, while iodide here is I negative. So it will become PbI2. Okay? Next, Mg is 2 positive, nitrate NO3 negative. So it will become Mg in bracket NO3 2 times, right? Because the 2 here is taken by all NO3. So you have to put the bracket. Next, copper. Copper 1 is means Cu1 positive. Oxygen is O2 minus. So it will become Cu2O. Barium. Barium is Ba2 positive. Hydroxide OH minus. So it will become Ba in bracket OH 2 times. Sodium, Na positive, and carbonate, CO3 2 minus. So it will become Na2CO3, right? Lead-4. So Pb4 positive and sulfur is S2 minus. So both of them can be simplified, can be divided by 2. It will become PbS2. Okay? Next, K is positive. Oxygen is O2 minus. So it will become K2O. Now cesium. Cesium is Cs positive. Oxygen is O2 minus. So the chemical formula is Cs2O. Aluminum is in a group 3. So Al3 positive and sulfate SO4 2 minus. So the result is Al2 in bracket SO4 3 times. Okay? And Zn is always 2 positive, chlorine is Cl negative. So the result is ZnCl2. Okay? Now let's discuss about naming chemical substances. Let's start with naming ionic compounds. When naming an ionic compound, metallic elements comes before non-metallic element, and non-metallic elements end with "ite." For example, I have the bonding between calcium and chlorine. So the chemical name is calcium chloride. It's not chlorine, okay? The non-metallic elements end with "ite." So it changed from chlorine to chloride. So calcium is a metal and chlorine is a non-metal. So it becomes chloride. Next, iodide and lithium. So the name will be metal, next followed by the non-metal. So lithium comes first and then iodide. Next, sulfur and potassium. So potassium sulfide. Okay? In an ionic compound, if it contains of transition metal, a Roman numeral in bracket is generally assigned to indicate its valency. For example, iron 2 oxide and iron 3 oxide. So that means iron 2 oxide, so it contains of Fe2 positive, while iron 3 oxide, it contains of Fe3 positive. Next, copper 1 oxide and copper 2 oxide. If it's copper 1 oxide, then the ion is Cu positive. And copper 2 oxide, the ion of copper 2 is Cu2 positive. Lead 2 oxide, that means it is Pb2 positive. And lead 4 oxide, it means Pb4 positive. Next, how to name a covalent compounds. When naming a covalent compounds, the first element name remains unchanged, while the second element name ends in "ite." If necessary, prefixes are used for the second element, in which it depends on its number of atoms involved. Now let's see at this table. For example, if I have one atom, then the prefix is mono. For example, like carbon monoxide. Why mono? Because it's contained of a single oxygen, one oxygen in here. Okay? Carbon dioxide. Why? Because it's contained of 2 oxygen atoms. So the name here is carbon dioxide. Next, carbon trioxide, because it contains of 3 oxygen atoms. Okay? And carbon tetrachloride, so CCl4, because it's contained of 4 chlorine atoms. Next, certain covalent compounds have some spatial names. For example, ammonia is NH3 and water is H2O. So this is an exception, and you have to really remember the chemical name and the chemical formula only for the spatial case like this. Okay? Next, to write the formula of acids, you have to follow some rules like this table. Hydrochloric acid, as we know, all acid will contain H positive ions. Okay, so hydrochloric acid is contained from the word chloric, so it's chlorine. So chlorine is Cl negative, so H positive and Cl negative, so HCl, right? Nitric acid, so H positive for the acid, and nitric is from the word nitrate. So nitrate is NO3 minus. So I will take yours, you will take mine, become HNO3. Next, sulfuric acid. So H positive and sulfate. So it's come from sulfate. SO4, 2 minus, right? So H2SO4. Next, phosphoric acid. H positive and phosphorate. The ion is phosphate, so it is PO4 3 negative. So the chemical formula is H3PO4. Carbonic acid, H positive and CO3 2 negative. So the formula of the acid is H2CO3. Okay? Now let's do some practice question. Write the chemical formula for the following compounds. Okay, sodium hydroxide. So to answer all of this, we have to know each ion for this compound. So sodium, it is an A positive. Hydroxide is OH negative. So I will take yours, you will take mine, crisscross. The chemical formula is an AOH. Potassium iodide, potassium K positive, I negative. So Ki. Lithium Li positive, carbonate CO3, 2 negative. So it will become Li2, CO3. Sulfuric acid, it is H2SO4, and we already discussed this at the previous slide. Copper 2 chloride. Copper is Cu2 positive. Chloride is Cl negative. So CuCl2. Okay? Next, aluminum sulfate. Aluminum is in the group 3, so Al3 positive. Sulfate, it's come from the sulfate, SO4, 2 negative. So Al2 in bracket SO4 3 times. Iron 3 oxide. Iron 3, so Fe3 positive oxide is oxygen O2 negative. Fe2O3. Calcium is 2 positive sulfate SO4 2 negative. So they can cancel each other. So the chemical formula is CaSO4. Zinc is always 2 positive. Phosphate PO4 3 negative. So the chemical formula is Zn3 PO4 2 times. So you have to put the bracket 2 times. Magnesium Mg2 positive. Nitrite is the nitrogen here. So nitrogen is N3 negative. So Mg3N2. Next one. Potassium chloride. Potassium K positive, Cl negative. So KCl. Sodium Na positive and Br negative. So NaBr. Potassium nitrate. So potassium K positive, nitrate, NO3 negative. So KNO3. Calcium hydroxide. Calcium Ca2 positive, hydroxide OH negative. So Ca in bracket OH 2 times, right? Potassium K positive sulfate SO4 2 minus. So K2SO4. Zinc hydroxide Zn2 positive, hydroxide is OH negative. So Zn in bracket OH 2 times. Okay. Aluminum Al3 positive and OH negative. So Al in bracket OH 3 times. Copper 1 sulfide. So copper 1, it means Cu positive, while sulfide here, it is S. Okay, it's not sulfate, it's sulfide. So S2 minus. Okay, because it is in a group 6, which is the same with oxygen. So Cu2S. Iron 3 chloride. Iron 3, so Fe3 positive, chloride Cl negative. FeCl3. Iron 2 hydroxide. Iron 2 Fe2 positive, hydroxide OH negative. So the chemical formula Fe OH and then in bracket 2 times. Iron 3 Fe3 positive and S2 negative. So Fe2S3. So the clue here, to solve the chemical formula of a compound, you have to know what is the ion that involved. Okay? Now let's move to this exercise. Name the following substances. To know the naming of a compound, then you have to know the ions that contribute to them. Okay? So magnesium, it contains of Mg2 positive and Cl negative, right? So the name is magnesium chloride. KNO3, K positive, NO3 negative. So the name is potassium nitrate. Iron sulfate. Remember, sulfate, because iron is a transition metal, so it can contain of iron 2 or iron 3. But sulfate is SO4 2 minus. But in here, we don't have the 2. So from here, I know iron must be 2 positive as well. So they can cancel each other and become FeSO4. Because this is iron 2, so that's why the name here is iron 2 sulfate. And you can see in here, Fe, but here is 3, right? So it's very clear this is Fe3 positive and carbonate is CO3 2 negative. So the name here is iron 3 carbonate. Next, K3N, so K positive and N3 negative. So the name here is potassium nitrite. So sulfate is always 2 negative, right? For Pb, it can be Lead2, it can be Lead4. But in here, we don't have the 2 in bracket, so that's why the Pb here must be 2 positive. Because it is 2 positive, so the name here is Lead2 sulfate. Next, copper. Copper can be copper 1 or copper 2, but we always know hydroxide is negative 1, but in here is 2, right? So it's taken by hydroxide because the clue here is I will take yours, you will take mine. So here it's very clear, must be Cu2 positive. That's why the molecular formula here is CuOH 2 times, right? So the name here is copper 2 hydroxide. Next, SO2. Again, this is covalent compound, right? So sulfur and how many oxygen we have here? 2 oxygen. So the name is sulfur dioxide. Next, NH4OH. So NH4 is NH4 positive and OH negative. That is the ion, right? So the name here is ammonium hydroxide. AlF3, Al3 positive and fluorine negative. So the name here is aluminium fluoride, okay? Now let's talk about how to balance chemical equation. So first of all, we have to write all the chemical formula of reactants and products, and then balance the equation. And there must be the same number of atoms of each element on both sides of the arrow. Write the state of each reactant if needed in brackets. In bracket S, that means to indicate a solid, L to indicate a liquid, G for gas, and AQ to indicate substances that dissolve in water. Okay, let's take an example in here. Before we start, you have to know some kind of the mathematics distributive law. For example, 2 in bracket x plus 3y. So how to solve this? This is what we call distributive. So you have to times number 2 with everything inside the bracket. So 2 times x is 2x and 2 times 3y is 6y. Okay? Okay, and I think that you know there's so many tutorials or the way to balance chemical equation in the YouTube. But I found there is a one way we can solve balancing equation faster in a few seconds. Okay, how is it? So the clue here is you have to put hydrogen and oxygen. These you put at the last. If you find any hydrogen or oxygen element, you don't care about it first. Just focus at the element which is not hydrogen or oxygen. Take one example. Okay, so in here we have C3 at the left, but at the right we only have C1, right? So we have to put the number 3 in here. Remember, balancing equation, it means you put the number in front of the compound. Okay, you cannot put it in the middle, okay? It should be in front, which is coefficient. So in here, the carbon is 3 right now, and here is 3 times 1 carbon, so the carbon here is also 3. Now next, what about the hydrogen? Hydrogen here is 2, but in here I have 8 hydrogen. So that's why I will put 4. Now hydrogen is also 8, right? Next, oxygen in here is 6, while oxygen here is 4. So altogether, the oxygen here is 10. So what is the number that I put in front of oxygen so we can get 10? I will put 5 because 5 times 2 is 10. So at the end, oxygen here is also 10. Okay? So now the balancing equation is 1, 5, 3, 4. Okay? Okay, so where should I start this from? I will start it from S3, right? And also Al2. So in here, the Al still 1. So that's why I will put 2 in front. And the S here still 1. So I will also put 3. But just because I put 3, hydrogen is also get affected. So hydrogen in here is 6. While here, the hydrogen also got affected. So 3 hydrogen H3, right? and then times 2, hydrogen here is 6. So altogether, hydrogen is 12. And what number should I put in front of H2O? 6, right? So I can get 12. So hydrogen here is also 12, which is balanced. Now, just because I put 6, now the oxygen also got affected. So oxygen here is also become 6. What about at the right side? Oxygen here is OH 3 times, right? So O3 and then times 2, oxygen is 6. And Al2, 2Al. S3, 3S. So the final answer here is 1, 6, 2, 3. Okay? Now let's take a look at this one. So where should I start this equation from? I will start it from Cl2. Okay, this one. Why? Because at the left side is the Cl still 1. So I will put 2 in here. Now, what is the other? Magnesium is 1 at the left and magnesium is also 1 at the right. So it's already balanced for magnesium. What about hydrogen? Hydrogen here is 2 and hydrogen here is also 2. So altogether, hydrogen is 4. So that's why I will put 2 in front of H2O. So hydrogen is 4 and they are balanced already. Now, just because you put 2 in front of H2O, now the O also got affected. So at the end, oxygen in here is 2. And yeah, that's already balanced because at the left side, we have OH in bracket 2 times. So everything in the bracket will be times by the factor of 2. So O2, H2. So the oxygen here is also 2. So the final answer here is 1, 2, 1, 2. Okay? That is how the easiest and faster way to balance the chemical equation. Now let's do some exercise. So how to solve this question? So we see in here Zn 1 and here Zn is also 1. While chlorine is 1 and here chlorine is also 1. But hydrogen here is 2. So that's why I will put 2 in here. Just because I put 2, now chlorine also got affected, right? So I will put 2 in here. Now, just because I put 2, now Zn is also get affected. So that's why I will put 2 in here. Okay? So the final answer here is 2, 2, 2, 1. Okay? Remember the rule, hydrogen and oxygen, we put this at the last. Okay, next. Where should I start this from? I will start from chlorine, right? Because Cl2, while here is still Cl1. So I put 2. What about the carbon? Carbon here is 1, carbon here is 1, Ca1, and here is also Ca1. So now let's focus on the hydrogen. Hydrogen here is 2, and hydrogen is also 2. While oxygen here is 3, right? Because oxygen here is 1, and here oxygen is 2. So altogether, the oxygen is 3, while oxygen here is already 3. Okay? So the final answer here is 1, 2, 1, 1, 1. Next, where should I start this from? You can see in here Ba3, while in here it is still Ba1. So I will put 3 in front. Just because I put 3, now the OH is also get affected. But we have the OH, so just put it at the last. Now PO4 2 times, while in here the PO4 still 1 time. So that's why I will put 2 in front. Now, just because I put 2, oxygen and hydrogen in here also get affected. Okay, so let's focus on the hydrogen in this part. So hydrogen in here is 6, while hydrogen in here is H2 times 3. So hydrogen here is 6. So altogether, at the left side, hydrogen is 12. So what is the coefficient that I put in front of H2O? I will put 6, right? Because 6 times 2 is 12. So at the end, hydrogen at the right side is also 12. So 3Ba, Ba3. What about the oxygen? So oxygen at the left side is how many? Oxygen here is 2 times 3, so 6. And here, the oxygen here is 4 times 2, 8. While here, at the right side, oxygen is 8, and here oxygen is 6. So they have the same number of oxygen, which is 14, both left and right side. Okay, so the final answer here is 3, 2, 1, 6. Next, Si1, Si1, C1, C1. So just focus on oxygen at the last. Okay, so O2 while in here is still O1. So I will put 2. Now the C also got affected. I will put 2 in front of C. So the final answer here is 1, 2, 1, 2. Okay, next, N2 while in here still N1. So I will put 2. So the hydrogen here is affected. So it will become 6. And that's why I will put 3 in front of H2. So the hydrogen here is also 6. So the final answer here is 1, 3, 2. Okay? Now let's talk about ionic equation. To write an ionic equation, state symbol of the substances must be clearly indicated. Solid, the symbol is S, liquid L, gas is G, aqueous, it means it is a substance that can dissolve in water, AQ. Okay? Next, determine the state of each substance. Substance that dissolve in water, we call it AQ, which is include all sodium, potassium, and ammonium salts, all acids, and all nitrates, and barium chloride, and also copper sulfate. For the ionic compounds dissolved in water, or AQ, separate all ions and write the charges on each. And finally, remember this is very important, you do not ionize solids, liquids, or gases. We only focus split the ions which has the symbol of AQ. And then we cancel ions that appear on both sides, and this is what we call the spectator ions to write the net ionic equation. Now let's see this word example. NaCl equals AgNO3 equals AgCl solid and NaNO3 equals. So remember, based on the rule before, we only split the equals. Do not ionize or do not split the ions that have the symbol solid, liquid, or gases. So from here, I will split the ions, which is contained of Na positive and Cl minus. And this one is Ag positive and NO3 negative. In here, we do not split the ions. Na positive, NO3 negative. And then we cancel the ions that exist both left and right side. So NO3 exists at the left and NO3 exists at the right. What is the other? Na positive here is also Na positive. So at the end, you will have Cl negative and Ag positive, right? So the final answer here is Ag positive AQ plus Cl negative AQ will produce AgCl solid. Next, barium chloride. Okay, so barium chloride is aqueous, right? So you can write this, the symbol here is BaCl2. While sulfuric acid is H2SO4. Barium sulfate. So barium sulfate is BaSO4. And hydrochloric acid is HCl. Now you split based on the ion. So this is Ba2 positive and Cl negative. Remember, what is the state for barium chloride? It is aqueous. All acid also aqueous. While here barium sulfate is solid and hydrochloric acid, again, it is also an acid. All acid can dissolve in water and that's why it is aqueous. So we split the ions of sulfuric acid H positive, SO4 2 negative, and HCl, H positive and Cl negative, right? And we cancel the ions which is H positive, Cl negative, Cl negative. So at the end, you will have Ba2 plus and SO4 2 minus. And this is the answer. Okay? Next. Iron. What is the symbol of iron? Fe, right? And iron, this is a solid. Nitric acid. As long as it's contained of acid, of course, it can dissolve in water. So what is the symbol of nitric acid? HNO3 equals, right? And iron 2 nitrate. So Fe in bracket NO3 2 times. And this is equals. And plus hydrogen is a diatomic gas, so I have to put 2. And this is a gas, okay? So we split the aqueous based on their ions. So H positive and O3 negative. And this is Fe, 2 positive and NO3 negative. Okay, so these gonna be cancelled out. And at the end, you will have Fe solid plus 2H plus, because we want to balance the H2 in here, right? This H is 2, so that's why we put 2 in front, because the H here is still 1. And we'll give you Fe2 positive equals plus H2 gas. Now let's talk about half ionic equations involving electrons. A half equation is used to represent what happens when atoms or ions gain or lose electrons. In half equation, electrons are shown as E negative. The number of atoms of each element must be the same on both sides, and this is the reason why we learned about how to balance chemical equation before. The total charge on each side must be the same, or usually equals to 0. Let's take a look at this example. Okay, in here we have ions, and in here we have atoms. So that means it is from ions want to become atoms. Imagine if I have like this H positive want to become H2. So how many H at the right side? 2H. So that's why I will put 2 in here. So now just because I put 2, so the charge at the left side is positive 2. So where should I put the electron? So imagine if you put the electron at the right side. Okay, how many electron? Let's say you put 2 electron at the right side. So electron is negative, while here the charge is 0 because there is no ions, right? And the charge at the right side is negative, so this is going to be negative 2. So it is not balanced because at the left side is positive 2, while at the right side is negative 2. So that's why this is wrong. And I have to put the electron at the left side, okay? So H2 in here, and I will put 2 in front. Now, just because I put 2, the charge here is positive 2, so that's why I will put the electron in here. So 2 electrons. So positive 2, the electron is negative 2. So positive 2 and negative 2, all of them will add up to 0. And hydrogen, H2 is 0. So they are already balanced. That is how you do the half ionic equation involving electrons, okay? Next, Ag positive become Ag. So how many electrons? 1 electrons. Zn, and here is also Zn1. So you don't need to put the coefficient again, just focus on the number of charge in here. So 2 positive, so how many electrons to make it balanced? 2 electrons, right? And copper, 2 positive, so you need 2 electrons to make it balanced. Next, OH negative become O2 plus H2O. So in this case, you have to balance the chemical equation first. So I will put 4 in front of OH negative, and I will put 2 in front of H2O. So how many hydrogen in here? 4. And oxygen here is 2. Oxygen here is also 2. So altogether will add up to 4. And at the left side of oxygen is also 4. Now just because I put 4 in front of OH negative, so the charge here is negative 4. So that's why in here it should be negative 4 as well. So that's why I will put 4 electron. Okay. Next, Cl2. This one still Cl1. So I will put 2. Just because I put 2 now, the charge is 2 negative. So I need 2 electron to make it balance. Fe2 positive. Okay, so I need 2 electron. And A positive, I need only 1 electron. Okay. Now let's see the molecular mass calculation. Measuring the mass of an atom is extremely difficult as atoms are extremely small. Chemists have devised a method to overcome this difficulty by comparing the atom to an isotope of carbon with the mass number 12 as the standard, because it is a stable isotope and can be measured very accurately, making it a reliable standard for comparing atomic masses. Relative atomic mass, or AR, of an element is defined as the average mass of one atom of an element compared with 1/12 of the mass of carbon-12 atom. To calculate relative atomic mass for isotopes of the element, this is the formula. So sum of the isotope mass times with the percentage. Now please look at the word example here. Bromine has 2 isotopes, Br79 and Br81. Both exist in equal quantity. Calculate the relative atomic mass of bromine. Okay, so how to solve this question? We know 79 and 81, right? So the total here will make 100%, and they both exist in equal quantity. So 100 divided by 2 with the same number quantity. So both of them will have 50%, right? So 79 times 50% and plus 81 for this bromine. So 81 times 50%. And then just do the normal mathematical calculation, and this is the result. Next, chemists discovered that neon element has 3 isotopes. There are 90.92% of these neon and 0.26% of 21 neon and 8.82% of 22 neon. Now determine the relative atomic mass of neon element. Okay, so again, so 20 neon, right? How many percent? 90.92. So this one. And remember, we always take the bigger number, which is the mass number, while the smaller number, this is atomic number or proton number. For 21 neon, this is 0.26. And for 22 neon, this is 8.22. And just do the normal math calculation, and this is the result. Okay? Now let's talk about the empirical formula calculation. So empirical formula is the formula showing the simplest ratio between the elements. For example, like CH3, CH4, CH2O. Empirical formula can be obtained from the given data of the elements of a substance in the term of mass or percentage. For example, a compound has 80% of carbon and 20% of hydrogen. Determine its empirical formula. So please look and follow this step. So first of all, we write the symbol of each element. So we have carbon and hydrogen in here, right? So we write carbon and hydrogen. Next, we put the percentage, or sometimes in the question, they will give you the mass, okay? So just put the number in here, 80 and 20. Write down the mass or the percentage given. And then we divide by each relative atomic mass. If you check in the periodic table, the mass for carbon is 12 and hydrogen is 1. So what is the result of 80 divided by 12? 6.67, and 20 divided by 1 is 20. This is the result of division. And after that, we divide by the smallest value to get the ratio. So who is the smallest number between 6.67 and 20? It is 6.67, right? So all of these carbon and hydrogen, we divide by this number, okay? And remember, the final ratio here should be a whole number. And finally, you get the empirical formula, which is CH3, okay? Next word example. In leaded petrol, there is an additive composed of lead, carbon, and hydrogen only. This compound contains 29.7% carbon and 6.19% hydrogen by mass. What is the value of X in the empirical formula PbCH8HX? So how to solve this question? So we have to find what is the percentage of Pb. So because he say we only know the carbon and hydrogen, right? So all together, they will add up to 100%. So 100 minus the percentage of carbon, which is 29.7, and then minus the percentage of hydrogen, which is 6.19, then you will get this value, 64.11. Okay, so now everybody is known in here. Next, you write the element, and you write the percentage in here, lead, carbon, and hydrogen, and divide by their relative atomic mass based on the periodic table. And the result of this division is this. And after that, you divide by the smallest value. So who is the smallest value in here? 0.31, right? So all of them divide by 0.31, and you will have this, 1,820. So that means this is Pb1, C8, and H20. So the X here represents hydrogen. So the value of X equals to 20. Okay? Now let's talk about the molecular formula calculation. So molecular formula is the formula showing the actual ratio between the elements. For example, C2H6. So this is the molecular formula because it's showing the actual ratio. But if you divide this by 2, then you will get CH3. And this is what we call empirical formula because it's showing the simplest ratio. If you divide this one by 3, then you will get CH4, right? And this is the empirical formula. And if you divide this by 6, so you will have CH2O. Now let's see this word example. The empirical formula of a substance is CH3. Its actual molecular mass is 30. Calculate molecular mass of the empirical formula. So how to solve this question? First of all, we have to calculate the molecular mass of the empirical formula. 12 plus 3, right? This is from CH3. Carbon is 12 and hydrogen is 1. But we have 3 hydrogen, so plus 3 equals to 15. Next, divide the actual molecular mass by the MR of empirical formula to find the ratio, right? So 30 divided by 15. So you will get 2. And then multiply the ratio with the empirical formula to get the molecular formula, which is C2H6. Because we times the ratio is 2. So we times everything in here from the empirical formula times with 2. So C2H6. Okay? Now let's see another word example. A compound consists of 20.32 gram of carbon, 5.12 gram of hydrogen, and 7.9 gram of nitrogen. What is the empirical formula? Okay, so we have carbon, hydrogen, and nitrogen. So you just put everything in here, the mass. Sometimes it can be in percentage. Please remember that. Okay, and then we divide all of them by their atomic relative mass. So the mass of carbon is 12, hydrogen is 1, and nitrogen is 14. So you can use the calculator to count this, and you will get 1.693. 5.12 divided by 1 is 5.12. 7.9 divided by 14 is 0.564. And after that, you divide all of them by the smallest value. Who is the smallest value? 0.564, right? So all of them divide by 0.564. In here, you will have 3 and 9 and 1. So the empirical formula here is C3H9N. Next, what is the molecular formula if the molar mass MR of the compound is 236 gram per mole? Okay, so we have to find the MR of C3H9N. So how many carbon? 3 carbon and 1 carbon, the mass is 12. So times 12 and then plus 9 times 1. The mass of hydrogen is 1 and plus nitrogen. The mass of nitrogen is 14. And then just do the normal math calculation in here. So 36 plus 9 plus 14. So equals to 59. Okay. And next we find the ratio. So the ratio is 236 divided by 59. Then this is 4. So what is the molecular formula here? So C3H9 and all here you times with 4, right? Because the ratio is 4. So the molecular formula is C12H36 and N4. So this is the molecular formula. Okay? So that's all about this chapter, Stoichiometry Part 1. We will discuss some past paper questions related to this topic in the next video. Thanks for watching. Don't forget to like, comment, and subscribe. See you in the next video.